Hi Physics, Stephen Zawicki, your physics teacher. Today we are going to be doing some analyzing of projectile motion through video analysis. And hopefully by the end of this we'll have some definitive evidence for or against our different postulates. So the first thing that you're going to need to do is you're going to have to record your own video, or you can use the video I provided that is attached to this assignment. Then the program that we're going to use is a website to analyze our video. So we're going to go to this website and we're going to open the app. That's the next step. I already did some analysis, so it's asking if I want to keep my file, but I'm going to do a new one. So we're going to select a local file, go to projectile motion analysis. So we're going to open that up. While that's opening up, right, this is step number 3. All right, we need to give it a name. I recommend you call it projectile motion analysis. And all of this is doing well, right? The video file is 30 frames per second. I can't raise this. Actually, record a camera FPS. Let's see if I can make it up higher. Actually, no, I want it to go down because it's only recorded at 30 frames per second. So we're gonna create. All right, now there's a bunch of stuff that can be going on here. So the first thing that we want to do is we only want to start our video when my projectile has left my hand. So here I am, I'm out of the street, took this video this morning, and my projectile is a frisbee. And so I'm going to click on this and I'm going to move my video until I can click play up here. I'm going to click play until it leaves my hand. And so I'm going to move it over. I think it's left my hand, but I know that right here the frisbee is definitely no longer in contact. So I'm going to move my axes so that it's right at the center of my object. Okay? And you can just do that by clicking right at the vertex between the lines. And we don't want to rotate it. If you wanted to rotate it, you can click on this part here. But we want to have straight up and down. That's going to be the best part for us. All right, the next thing is I need a scale. I need to know how much distance each pixel is. So on the right side of your screen, you're going to see Create Scale. I'm going to click on that. And let's make it, I don't know, I'm going to make it blue. Let's make it a light blue so that it stands out against the dark parts of my body. Click here and I'm going to create. And then what you can do is you can click. And now you have 2 points. I'm going to take that from my head down to my toes. And I am 1.7 meters. All right, so now my scale is set. And that means that every time I make a new data point, then it will record that as an actual distance. So it's going to do the conversion for us. Sweet. Now we can start taking data. So I'm going to click on Create New Track. Let's call this the frisbee. And let's make it like orange or something like that. Yeah, beautiful. We're going to create it. Now, to take data points, you need to click the Shift button. Notice that my axes are gone. And each time I click, it's going to move the frame forward once. So I'm going to click here. And it didn't move forward, so what I'm going to do is I'm going to move my frame. There we go. And I can click right in the center. Now it's moving. Okay, got to move it forward again. Keep on going. Move it forward again. Move it forward one more time. And now it's collided with the ground and I don't want to take any more data. All right, so we are done with data collection. That goes really quickly. All you got to do is click that button several times, and you get your data. Notice on the right side, we now have a data table that's filled everything in. So this is all the steps for taking this data, right? Once you've created a track, keep doing it until we finish plotting all of our data. So the next thing we need to do is we need to go to desmos.com. Desmos. Beautiful. And then it tells us that we should open a new tab, and at the top of the page, we're going to go to Graphing Calculator. So there's Math Tools, Graphing Calculator is where we want to go. All right. So this is what it looks like. I can zoom in and out. There's a bunch of different stuff here. The first thing is we're going to go to Add Item, and we are going to put in a new table. We can get rid of this piece right here. And what we're going to do is we're going to highlight this entire thing, and we're going to Control C, and we're going to paste it right in. Look, it made a new thing. I don't want this then. Let's get rid of that. And here is our data. Beautiful. So notice that it starts, the x-axis is going to be time. So what I'm going to do first is I'm going to change this to time. We'll call it 1. This will be x1, and this will be y1. Okay. So now our axes are labeled. I can actually change that here. We can call this time, and we can call the x-axis or the y-axis position, right? Because it's plotting both the x position and the y position. This is what it's showing us. Okay. So down at the very bottom of the page, right? So now we've done +1. We've added it in to help us understand the graph. We're going to click on those labels, change it to the t, x, and y, which we did. Now the next thing is we need a line of best fit. So this is what step 15 is going to do for us. So down here you'll see this number 2. We're going to click here, and we are going to add in the equation for the line. So right now on the x-axis is time, right? T1, and we're going to use the tilde function, or the tilde button that should be in the top left-hand corner of your keyboard. Otherwise, you can always just copy and paste it from here. Notice I say type into the section this part. Oh, actually, it's not T1, it's X1. Okay, and then MT1 plus B. And notice I now have a line of best fit on my page. So I can see that my parameters, M is going to be 2.3, and my y-intercept is -3, right? I can go down here, look at it. Okay. So remember that on a position versus time graph, right, we have a slope. So this is what the M is. All right. The next thing is we want the line of best fit for our y position. And notice that it's curving, right? There's some curving to this. So we're going to have to use a different equation. So it's going to be y1 is about equal to, and we type in something different here. We type in a t1, right? And then we're going to do the caret, which puts us to the powers, and we're going to square that. Then we're going to add in b t1. Oh, notice my line of best fit is fitting in here, and then plus some constant. And now my graph is covered. And so I have all of these different values here, and it's going to be up to you to figure out what this means based on how we've analyzed some of our graphs in the past. Okay, so this is how you're going to operate the lab. Once you have this all done, you need to answer the analysis questions and determine which of our postulates are rules for projectile motion. See you later, AP Physics, or see you later, regular physics.